Hello and welcome to this tutorial, and this is Casey. In this video I'm going to show you how to now solve repeated linear factors, and this problem has two combination of non-repeated linear factor at the denominator and a repeated linear factor. So we're gonna tackle this and see what's the outcome. So let's start by giving the first constant x plus 1. The second constant will be x minus 2. And the last one is x minus 2 raised to the power of 2. If you don't know why we are doing this, please watch the previous video for your understanding. So the common denominator is x plus 1, x minus 2 squared, x plus 1, x minus 2 squared, x plus 1, x minus 2, x minus 2. The reason why the value of b I've multiplied by x minus 2 twice is just to simplify our cancellations so that you see what remains once I cancel out the denominator. So don't confuse it to be like a different way of just expansion of the squared factor for ease of understanding. So let's go ahead and cancel out. So our equation now becomes 5x squared minus 6 is equals to a in brackets x minus 2 squared plus b in brackets x plus 1 x minus 2 plus c in brackets x plus 1. I would expand this so that I collect like terms, but before I do that, I want to show you that once you have one linear factor given in your equation, you notice that we can actually solve for one constant. And in this instance, we're going to solve for the constant a by making x is equals to -1. So let's go ahead and do that. We have 5 in brackets -1 squared minus 6 is equal to a -1 -2 squared plus b in brackets -1 plus 1. Of course that will go -1 minus 2 plus c -1 plus 1. So let's cancel out. So b will go and c will go. We'll remain with the values of a. So 1 squared is equals to 1 multiplied by 5 is equals to 5 minus 6 is equals to -1 equals to -3 squared is equals to 9. So we have 9a. Therefore a is equals to 1 over 9, which is of course a negative value. Now the reason why I usually take this approach is because even if you go ahead and expand the other values, it becomes so easy for you to plug in the values instead of solving linear equation or matrices. One thing you'll observe is that since we have another linear factor under b, we can equate it to 0 and get the value of x equals to 2 so that we can either solve for b or c. So we say x is equals to 2. Therefore, we have 5 in brackets 2 squared minus 6 is equals to a 2 minus 2 squared plus we have b 2 plus 1 2 minus 2 that goes plus c 2 plus 1. Let's do our cancellations. You notice that a goes and also b goes because the other factor is 2 minus 2, and then we remain with 2 plus 1. So we have 2 squared is equals to 4 multiplied by 5 is equals to 20. 20 minus 6 is equals to 14 equals to, we see that here we have 3c. Therefore c is equals to 14 over 3. That's great. Mark it up. That's our solution. Now the next one is where we have to expand it so that we solve for b. From the top here, okay, we will see that 5x squared minus 6 is equals to, now the value of a is multiplied by x minus 2 squared. So x minus 2 x minus 2. Therefore, we have x squared minus 2x minus 2x plus 4. Therefore, we have x squared minus 4x plus 4. So the value of a is multiplied by x squared minus 4x plus 4. And the value of b, let's solve for b as well on this other side. X squared minus x minus 2 in brackets, and then we have c, which is now plus cx plus c. So expanding the values, we have 5x squared minus 6 is equals to ax squared minus 4ax plus 4a plus bx squared minus bx minus 2b plus cx plus c. Now, since I've introduced to you how to use the coefficients of x, we will see which values give us any equation that has a plus b or a plus b plus c, so that we can solve for b. So we have the coefficients of x. We have 5x squared, we have ax squared, bx squared. Therefore, this will actually give us a solution to our problem instead of now doing the simultaneous equations as I've previously mentioned. So we have 5 is equals to a plus b. You'd notice that if we go ahead and solve for b, b is equal to 5 minus 1 over 9, which is equivalent to 5 plus 1 over 9, which is equal to, we have 9, and then here we have 45 plus 1, which is equals to 46 over 9. And this is our solution for the variable b. So let's go ahead and plug in the values of a. Is negative 1 over 9 over, we have x plus 1 plus the value of b is 46 over 9 divided by x minus 2 plus the value of c is 14 over 3 divided by x minus 2 squared. Simplifying, we have negative 1 over 9 in brackets x plus 1 plus 46, actually here is 46, sorry, over 9 x minus 2 plus 14 over 3 x minus 2 squared. And we've come to the end of my tutorial on repeated linear factors. In the next tutorial, I will go work on a proper rational expressions that will require also a different approach using long division. Thank you and see you in my next video.